Okay, here we're going to look at how to graph this exponential function y equals 2 times 3 to the x. The first thing I'm going to do is I'm going to look at the initial value of 2. That's my y-intercept. I'm going to go ahead and plot that point first. Let's say that's right about here. I'll go ahead and label that as the point 0, 2. Again, this graph isn't going to be drawn to scale because I'm not going to be able to fit very many points on it if I were to try to be accurate with it. But then we'll just go from there. I'll just label the points so you can see what the coordinates should be. So we plotted our initial value of 2 on the y-axis. That's our y-intercept. Now, this growth factor here, 3, that we're going to go ahead and take this value of 2 and we're going to multiply it by 3 each time we move one more x value to the right. And as I go to the left, I'd be doing just the opposite. I'd be dividing it by 3. So if I move over here, let's say this is an x-coordinate of 1 right there. This y-coordinate of 2 is going to get tripled. It's going to get multiplied by 3. So at that point would be, let's say, right here. And let's say that is the point 1, comma 6. 2 times 3 is 6. And then the next point, when I moved over to 2, we'll take that one and triple its y value. So it will go from 6. 6 times 3 is 18. So there'd be another point up here, let's say at 2, comma 18. And so on. Apparently there's a cat in front of my computer. No cat. So then the next one, if I wanted to do 3, again, it would just take that y value of 18 and it would triple it as well. So that would go up to 3, comma 54, like that, and so on. If I was going to the left, if I went to -1, again, I'd just be dividing by 3. So instead of having 0, 2, I'd have -1. If I took 2 and divided it by 3, I'd have 2/3. So I'd have -1, 2/3 would be this point right here. And then if I went over to -2, over there, I'd have to take that and divide it by 3. -2/3 divided by 3 would be 2/9. So I'd have -2, 2/9 right there. Again, this is really hard to read my graph, I'm sure, but as you can see, you should start to see this exponential shape taking place. So I didn't miss the point there. And so on. Again, we're not going to be able to create very accurate graphs of these for that reason. I said it's going to very quickly get off the charts, if you will, and not be able to fit on there, or very quickly get so small that I can't be precise enough trying to plot that by hand. But just to get the idea, you would have an initial value of 2, that's your y-intercept, and then every time you moved 1 unit to the right, your y value would triple. Starting out at that initial value of 2, it would go to 6, and then to 18, and then to 54, and so on. As I moved 1 unit to the left each time, it would get cut by a third. It would be multiplied by a third, or divided by 3, like that going in the other direction. I wanted to look at a second example really quick. Like, let's just say I had y equals 4 to the x. Just a rough sketch of this. Again, the initial value there, the y-intercept, would be 1. Remember, when I don't see that a value in front of there, it's kind of camouflaged. So this point here would be, let's say, 0, 1. And when I moved over here 1 unit, it's going to take that y-coordinate and multiply it by 4. That's what this number here does. So I'd have 1, 4 as another point. If I wanted to go to the left, over here to -1, I'd have -1, comma 1/4. I just took it and divided by 4 instead of multiplying by 4. If I wanted to go another one to the right, I'd have 2, and again times 4. 4 times 4 would be 16, like that. If I wanted to go another one to the left, to -2, I'd have this other point really low here. It would be -2, comma 1/16 for those points. Just a rough sketch of what that should look like. Yeah, you probably won't have to do too many questions where you actually have to graph these by hand, because I said very quickly it gets very large or very small for a lot of these, and it's really hard to make an accurate graph.